Hello everyone. Evaporation is an important process in the water cycle where water changes from liquid into water vapor due to heat from the sun or any other means. It plays a key role in weather patterns, climate, agriculture, and water resource management. It is important to measure how much water is lost through evaporation. Accurate measurement helps scientists and engineers manage water resource more effectively. In this lecture, I will try to explain the different methods used to measure evaporation. Evaporation is one of the largest outflow in the water balance for many systems. Accurate measurement helps us in several critical ways for planning and operationing of reservoirs, canals, and any other irrigation systems. The evaporation is a critical and important data. In water scarce regions, every drop counts. Precise evaporation measurement help engineers to design better lining for canals to reduce losses, select more efficient irrigation methods. The method which we will discuss in this lecture will be experimental method, empirical method, and analytical method. Evaporation in the field can be measured by evaporatometer, evaporimeters. In India, Indian Standard Pan Evaporatometer, as per Indian Standard 5973, is widely used. Next, the US Class A evaporation pan, which is the standard in the United States, is a circular pan of diameter 1.2 meters, 1.2 meters dia, and 25 mm deep. This is US Class A evaporation pan. It is also widely used globally. The another uh, famous pan is Colorado sunken pan. This is a square pan of dimension 3 feet by 3 feet. It is buried in the ground with the rim just above soil level. The another famous or used evaporatometer is US Geological Survey floating pan. This one floats directly directly on the lake or directly on the lake or water body. So it better simulates actual large body evaporation by matching water temperature and other conditions. Uh, in India, the Indian Standard Pan Evaporatometer as per Indian Standard 5973 is used. This is a cylindrical reservoir or pan of diameter 1220 mm and depth 255 mm. Very similar, it is very similar in the size as that of US class A pan, but with some Indian specific design features. Water is maintained at a fixed level using a fixed point gauge mounting in a stilling well. Here it can be seen there is a stilling well whose water level is same as the rest of the part of the evaporatometer. There is a perforation in the bottom of the well. This is stilling well. So, a stilling well is provided to avoid ripples and gives accurate readings. At each observation, usually daily, add or remove water in this stilling gauge. Add or remove water in this stilling well to maintain a fixed reading. And the water is added by a measuring cylinder, by another cylinder, measuring cylinder whose cross section area is 1 by 100th of the area of the evaporation pan. The pan evaporatometer shall be made from the copper or non-rusting, non-magnetic stainless still. This is the top view and side view of the pan evaporatometer, which is taken from the Indian Standard Code IS 5973. Each dimension is clearly mentioned in this figure. The pan evaporatometer or this reservoir is covered with the wire mesh netting to protect it from the any other animals or birds. A thermometer is also installed in the that pan evaporatometer to measure the temperature of the water in the pan. And also, an anemometer is installed nearby records the wind speed. Why? Because wind speed and temperature of the water highly affects the pan evaporation, as we have discussed in the factor affecting evaporation. Here, the readings comes from the pan evaporations will be different from the lake evaporation. Why? Due to shape and size factor. The lake is a higher surface area. However, the pan is a smaller in size. Depth is shallow in pan, but in lake there is a deep depth. Water quality is also different, and atmospheric pressure condition is also different for lake and pan. That's why a coefficient, namely pan coefficient, is multiplied with the pan evaporation, which gives the uh, evaporation corresponding to the nearby lake or water body. So in India, the for Indian standard evaporation pan, the CP is taken as 0.7 to 0.8. The World Meteorological Organization recommended the installation of evaporatometer or the number of uh, evaporatometer pan as per the zones or weather zones. For arid zones, one station for every 30,000 kilometer square. For humid temperature climates, one station for every 50,000 kilometer square. And for cold region, one evaporatometer must be installed for every 1 lakh kilometer square area. Usually, a hydrometeorological stations contains all these instruments like ordinary rain gauge, recording run gauge for measuring the temperature, wind anemometer, and this pan evaporatometer and other instrument as mentioned here. The another method or to measure the evaporation is empirical methods. The foundation equation for evaporation is Dalton's law of evaporation, proposed by John Dalton in 1802. It states that the rate of evaporation is proportional to the difference in vapor pressure between the water surface and the overlying air, with wind playing a key role in removing moist air. So here it is also a function of wind. So if we uh, just write the expression, we can write EL, that is lake evaporation, is equal to K into function of wind velocity into EW minus EF, where EL is the lake evaporation, K is the coefficient, FU is the wind speed correction function. EW is the saturated vapor pressure at the water surface temperature in of mercury, and EA is the actual vapor pressure of overlying air at a specified height. The another formula is given by Mayer's. Building on Dalton's law, one of the most widely used empirical formula is Mayer's formula, which states that EL is equal to Km into EW minus EA into 1 plus U9 by 16, where U9 is the wind velocity at 9 meter above the ground level. If wind velocity is given at another height, then it can be easily find out at 9 meter height by this formula. This is 1 by 7th power rule. Vz1 is the velocity at z1 height divided by velocity at z2 height is equal to z1 height z1 by height z2 to the power 1 by 7. So by this formula, the velocity at 9 meter height can be easily found if the velocity at another height is given. Another formula is Rover's formula, which states EL is equal to 0.771 into 1.465 minus 0.000732 PA into 0.44 plus 0.0733 U naught into EW minus EA, where PA is the atmospheric pressure and U naught is the mean wind velocity in kilometer per hour at ground level, which can be taken to the velocity at zero point 0.6 meter height above ground. Because at ground level, it is the value is very less. The another formula is Pinman's formula, which states EL is equal to 8.9 into 1 plus 0.15 U into EW minus EA. Here U is the wind velocity at 2 meter above ground level. The another method to measure the evaporation is analytical method, in which water budget equation, energy balance method, and mass transfer method is important. The water budget method is the simplest method of these three analytical method. It involves writing the hydrological continuity equation for the lake and determining the evaporation. The energy budget method is an application of the law of this conservation of energy. The energy available for the evaporation is determined by the considering the all incoming energy, incoming energy plus outgoing energy plus outgoing energy plus outgoing energy plus any storage is equal to constant. There is no change. And the last one is mass transfer method is based on the theory of turbulent mass transfer in the boundary layer to calculate the mass water vapor transfer from the surface to the surrounding atmosphere. And one of the important formula for mass transfer method is E is equal to 0.000119 E1 minus E2 into U2 minus U1 divided by P into ln H2 by H1 to the whole square, where E1 is the vapor pressure at height H1, E2 is the vapor pressure at height H2, U1 and E2 is the velocity of wind at height H1 and H2 respectively, and P is the mean atmospheric pressure. So, in this video, we have understood and discussed the different method to measure the evaporation. If you have any doubt, you may ask your question in the comment section below. I hope you have understood all the methods which we have discussed. Thank you. Jai Hind.